Hello, this is the video for the Fundamentals of Aero xflr5 project. I will be going through and working on doing the entire process for one of the wing plan forms that's required in the project as per the handout. So first we're going to start off by setting up our NACA 2415 airfoil. So we entered into the direct foil analysis tool. We're gonna go to foil, NACA foils, put in our digits, 415, 100 panels. And we are going to make sure all these values are correct. And then we're gonna save this. I already have this saved over for another project. I'm not gonna overwrite it. We're gonna go ahead and switch modules now to the analysis now that we have the geometry for the airfoil made. And we are going to set up our analysis definitions. So I ended up doing 2 meters chord. I left the mass as is, I put the span to 0. I did that since it shouldn't have any span, it's just an airfoil. I didn't really notice any major difference though in how it's calculated, so I think that's honestly not necessary. I'll keep it at 1 right now, but I've done it at 0 before. Not sure what happened there. There we go. Mach 0 and critical at 9. And looks like all my settings saved. That's interesting. But make sure the start is at -5, end is at 25. And then 1 degree increments, and we analyze. And we can see here that all the different all the iterations ran. The only one didn't converge. Looks like 8 degrees didn't converge. But we have from -5 to 25 with only 1 gap. Assuming that's why that's this discontinuity. I haven't been able to get 8 to converge, but it hasn't really affected my data in any way that I can determine. So this is just for the airfoil by itself. For the wing, we're gonna do a batch analysis at a variety of different Reynolds numbers. This is fine. This is what I had before. Analyze, have it run its batches. So complete the analysis. Now we have this number. This is what it looked like before. There's a few different Reynolds numbers that seem to tweak out. It hasn't affected my data in any way that I can determine. Everything looks solid for the wing, so I ended up I couldn't get rid of these discontinuities. I thought it wasn't wise to start chasing them. It's kind of impossible. So after this, I switched to wing and plane design, and then did the geometry. We're going to be doing the taper ratio of 1 for 7 aspect ratio. Make sure that everything else is turned off. Put on all the settings. Alright. For taper ratio of 1, the span that I calculated is 10.5, which when divided in half ends up being this. Select our airfoil and save. Now we have our wing geometry. And now we can define an analysis for our wing. Whoops. $50 meters per second. Analyze. Okay. So now if we go to our CL graphs, we can change here what this shows. We go CL, CD, have it show that, CL over CD. And then we can do CL over CD alpha here, which is already set. We'll do CD over alpha for this one. These are all our different graphs. These are all the graphs we need. It doesn't converge for the last three. I have not been able to get that to work the last four. I messed with the range for Reynolds numbers, doesn't really converge. As we said, basically, as long as you show CL max, that's all that really matters. So I ended up leaving it like this. I did some basic interpolation, but there's no, it's not really worth chasing this. I've tried. Nobody else was able to get any, come up with a solution that actually consistently worked. So, but yeah, this is the CD over alpha, CL over alpha, CL over CD, CL over D over alpha for one wing, and then for our local, we come over here. This is induced angle. We don't want all these different. Degrees or angles. We want only one. So we're gonna clamp both ends. Run again. We're gonna reset this first. And here we have our induced angle for this wing platform, and we're gonna go ahead and change it to lift, coefficient of lift, local coefficient of lift, and then here's our induced drag. So yeah, that's all the information. Basically just rinse and repeat for the 4 different wing platforms, and that's about it. So yeah, that's a video for the project.